evening, everyone. Thank you for joining us today for this exciting webinar. Transform your sample preparation, introducing the new meal for effortless greening of polymer and inorganic materials. My name is Asti Damayanti, and I'll be your moderator for today's session. On behalf of Frontier Lab, we're thrilled to have you here to explore the capabilities of our latest innovation, the IQ Meal 2070, designed to make sample preparation easier, faster, and contamination free. Before we dive into today's presentation, I encourage you to stay engaged throughout the session. Drop your question in the Q&A box at the top of your screen. You can choose it, and we'll address them during the Q&A session at the end of the webinar. We also have an exciting opportunity for you to win a $50 holiday travel coupon. And here is how you can participate. First, follow our Instagram account at frontierlab_C_PyroGCMS. Take a screenshot of this webinar and share it on your Instagram post. And don't forget to tag our account at frontierlab_C_PyroGCMS into that post. The best post that creatively highlights the webinar will win, and the deadline is on November 22nd before 11:59 p.m. Indian Standard Time. And the announcement will be on the November 25th, 2024 on our Instagram page. So keep an eye out for this notification. And then now it's my pleasure to introduce you to our speaker, Dr. Karthikeyan Satrughnan. So Dr. Karthikeyan Satrughnan is the Regional Technical Manager at Frontier Lab. He is a seasoned expert in advanced material analysis with a focus on pyrolysis GCMS. Today, he will guide us through the game-changing capabilities of the IQ Mill 2070 and how can it transforms your lab sample preparations process. Let's dive in, Dr. Karthik. The floor is yours. Dr. Karthik, can you hear me?
Hi, Asti. Yeah, thank you for the kind introduction. Also welcoming the participants on behalf of Frontier. Yeah, now let me share my screen, then I can get started with my technical part. Just help me to confirm whether you're seeing my screen.
Yes, we can see it.
Okay, all right. Thank you very much. Okay, hello, good afternoon, good morning. It's my pleasure to see you all remotely again for another interesting webinar at Frontier Laboratories. In today's session, I'm going to share about our new cryomill, okay, which is actually carrying a product number IQMill 2070. So you will see some of the features that actually helps to minimize your efforts on sample preparation. Let me quickly introduce Frontier Laboratories once again. Okay, Frontier Laboratories is a Japanese organization located in Koriyama, Fukushima Prefecture, and we have entered our 34th year of success journey. And we are a kind of global leader in analytical pyrolysis technology. So that means we carry a big market share. And our main manufacturing products are like pyrolyzer and its peripheral devices. As you know, pyrolyzer, the multi-shot pyrolyzer is one of our main product that has been used widely throughout the world. And we also have another interesting product called this a micro reactor that comes in a single reactor as well as a tandem reactor. This is more for catalyst screening as well as for this thermochemical conversion of biomass feedstock to some useful chemicals or fuels. To complement our analysis with pyrolysis GCMS, we have unique ultraviolet column, also this chemisober solid phase micro extraction device that can help you to really enhance the detection capability for certain volatile matters as well as for semi-volatile organic matters. In this product line, now we have recently added this IQML, which is more like a laboratory equipment for sample preparation, and that is useful for pyrolysis, GCMS, and beyond. Okay, as you all know that we employ a different analytical techniques when it comes to single particle analysis, starting from this atomic force microscopy coupled to infrared and also this laser direct uh, infrared, as well as this micro Raman or this optical photothermal infrared pyrolysis GCMS, then also this TEM, SEM, and asymmetric flow like field flow fractionation, so on and so forth. And many of these techniques deal with a very small particle size, starting from 1 nanometer, and it can go as high as like 1 millimeter size. So in all cases, it is important to have a homogeneous sample as well as a representative sample, so that the analytical data what we get out of the samples are really representative of the whole object that we are trying to characterize or show. So to really complement this sample preparation, we have recently developed a cryogenic mill, okay, so which actually is very compact, and it's a benchtop grinding mill with powerful and shear crushing capabilities. And we have some three unique features. One is, yeah, it's actually can do the crushing in short time and efficient, due to its design with this high-speed three-dimensional figure eight motion, and it's very like user friendly, and it comes with a simple operation guidelines. And most importantly, because some of the samples may require cooling to ensure that it's not hitting its brittle temperature or the glass transition temperature. So we have come up with a kind of approach to do a pre-cooling whereby we can reduce the consumption of liquid nitrogen during this crashing. So there may be a question popping up in our mind why we need a new cryomill and what is out there in the market and how it really add value to this technology. Okay, on the left side, okay, we just highlight some of the pinpoints, okay, or pain points in the existing technology. Okay, most of the existing cryogenic mill require a longer grinding time. Okay, yeah, it can go as high as like 10 minutes a time. We target to do something in very short time. So even like we are targeting to finish a grinding in 1 minute or less. And second is the usage of liquid nitrogen. On an average, most of the system require 10 liter of liquid nitrogen for each of the sample preparation, whereas we aim to have a less consumption of liquid nitrogen. And thirdly, it comes with very heavy weight. Again, yeah, with our benchtop design, the the total weight of the equipment is like we are aiming to keep it like 15 kilo or less. And the fourth and important point from customer perspective, can we also really make it like a cost benefit? So yeah, we try to keep the ownership cost also almost like half of what is the market price. So these are some of the kind of objectives our R&D team kept during this R&D project. And today we have a product, okay, that's actually IQML 2070 that can offer you a grinding in less than 60 seconds, and it consumes or uses less than 0.3 liter of this liquid nitrogen. Again, this 300 milliliter something can be used for few samples. It's not for every sample. And the instrument produce much less noise. So sometime when it is running in a laboratory, your co-workers do not even realize that there is IQ mill running. And absolute weight of this equipment is around like 12 kilogram, and price also, yeah, is somewhere around this 15K US dollar. So in grinding section, so our sample container actually can hold three different samples, okay, at the same time. But it is not necessary to have three samples all time. So that means the instrument allow you to run even with a single sample also. And this rotation is facilitated by using this high elastic belt, which is something a user can easily replace when it really got tired over the usage. Okay, so that means the design is very simple. So some of the replacement of the consumables can be done by the user. So this is the sample vessel, okay, where we put our crushing ball, okay, and basically the motion, as we said before, rapid reciprocating like torsional is more like a high speed gate motion, okay, and to really facilitate the grinding, we have come up with three different type of crushing ball. So during our earlier product launch, we had only like two type of crushing ball. One is the zirconium oxide based one, other one is the tungsten oxide one. Very recently, we have added another type of crushing rod. We will say it's made of stainless steel, and this is actually giving a better efficiency for certain type of material over other crushing ball. So in some cases, yeah, you may be satisfied with other two type of ball crushing ball as well as, but yeah, this stainless steel is a new addition to this crushing ball. And our sample container comes in two type of material. Again, yeah, previously we started off with only titanium oxide. Now, yeah, we also have stainless steel based one. On the right bottom, let me take my laser pointer. So this is the pre-cooling setup. Okay, basically it's nothing but a kind of beaker type reservoir which has a capacity of 600 milliliter, and you fill this with 300 milliliter of liquid nitrogen, and you immerse the sample container with grinder and sample together. Okay, generally when we do the first cooling 10 minutes, so in some samples, since we are doing a short time crushing, we may have to repeat the cycle. So it is recommended to cool the sample even before doing the second cycle of crushing or grinding. Okay, so first time it is recommended to use 10 minutes, then multiple the subsequent cycles, this is sufficient to cool it for like leave it there for 5 minutes. Okay, so as you know, we are more into this pyrolysis GCMS application. So we have taken an example to show how this crushing mill really helped to improve the data quality by this PY-GCMS. So we have taken a sample, okay, which is called a Vectran. It's basically a poly-4-hydroxybenzoic ran like hydroxynaphthoic acid. But in terms of its strength, it is 5 times stronger than steel. Okay, so it comes like a fiber-like material. So after grinding, you see them as a kind of powder, which has a particle size less than 100 micron. So in this slide, basically, yeah, we again summarize the grinding condition. So we have taken around like 0.25 gram of the sample and set the rotation speed RPM as the speed as 3000 RPM. Then the running cycle is 30 seconds and pause. And we do a 2 cycle grinding and also repeat 2 times. Okay, so the 2 cycles means instead of running it for 60 seconds, you run it for 30 seconds and give a pass, then do it. So when we say repeat, you repeat these 2 cycles for one more time. Okay, that is so. So for this repeat, you have to do the pre-cooling followed by the grinding. So we have compared the analysis of this material in two different conditions. One is cut the fiber, okay, into like this 2 mm of size, and another one is you do the grinding and use the ground powder for analysis. And we have taken a sample around like 0.1 milligram, and we have added a methyl stearate as a internal standard. Then we put some quartz gold just to make sure that the powder is not flying. Then we have analyzed by the pyrolysis GCMS, which actually, following this is more like a flash pyrolysis. Okay. And I'm not going to the details of the instrument technique. That's something pretty known for users. So you get a typical pyrogram, which comes with the phenol peak and 2-naphthol peak and methyl stearate. So just to see the reproducibility between this fiber as well as the sample powdered sample. So we have compared the ratio of this phenol and naphthol over this internal standard methyl stearate. And for sample A, I think you get around like 2%, 2.15 and 2.28. Whereas for sample B, which is coming after grinding, the powder one gives a much better reproducibility. So in terms of the RST percentage, RST is less than 1% for phenol and slightly over 1%. So in short, we can see that the powder sample gives better reproducibility than analyzing the fiber sample directly. So that's the point that we try to convey through these experimental results. So the important points, okay, while pulverizing a sample, okay, it's important to cool the sample thoroughly because, as I said, other models out in the market, they have continuous supply and they do the cooling during the grinding, whereas we try to do it before grinding, and whereby you can reduce the consumption of liquid nitrogen. And the cooling should really help to lower the temperature, lower than this embrittle temperature, and also much lower than glass transition temperature, so that the material does not get melted or decomposed during the grinding. So when we use cooling, like liquid nitrogen for cooling, so generally you achieve around like minus 196 degree. So since our cooling time is much short, we have to cool the sample vessel, crushing ball, and also even the insulation container. Okay, and all this because just to make sure that we are able to complete the crushing when the sample is like at low temperature or cold. So really to supplement the cooling effect, so we are recommending to cool the sample vessel, crushing ball, and thermal insulation container as well. Yeah, so the second important point is okay, the pulverizing the sample within short time, okay, because the sample has this heat by cleavage of these molecules, right? So when the temperature rises, it's difficult to pulverize the sample. So that's why we recommend to do this short time crushing or grinding. So even for 1 minute, instead of doing 1 minute in one stretch, we recommend you to do in like two steps, 30 seconds, 30 seconds. In between, you give a short pause. Secondly, to improve the pulverizing effect, we use a a heavy crashing ball like tungsten carbide, which has got high density. Now, stainless steel also has been added to this. Okay, so as I said before, it is important to complete the pulverizing process when the sample is cool enough. Okay, so that's why to supplement this cooling, we are cooling the sample together with sample vessel and the insulator. Now I have shot a video just to go through this process, how the sample is transferred to the sample container and this how the crushing ball is added. And yeah, so generally what we recommend, you can do the pre-cooling of the sample container and crushing ball, then you transfer the sample, then add a crushing ball, then put into the insulator, then you can do pre-cooling one more time also. So 2 times pre-cooling is recommended. So let me run this video. It does not have any audio, so uh, let me. Okay. Yeah, basically you keep the insulator and you keep the crushing ball outside when you are doing the pre-cooling before the sample. So initially, yes, we said it's recommended to do it for like 10 minutes. Okay. Then you transfer this into the sample container at the sample vessel and put the lid and you do that. Then you do one more time. Okay. So I think I have to. Okay, sorry, I just have to do one more time because it just run quickly. Just allow me to do one more time, okay? So you do the pre-cooling of the insulator and the crushing ball first, then transfer that to the sample container, then cool it together. Okay, so after cooling, you take out and yeah, you basically just keep the sample to this carousel and use these holes to get support for tightening. Yeah, okay. Yeah, I think that's bit of swapping happened. So basically, this video should come first where how we transfer the sample. Okay, yeah. Now I will show the easy 5 steps of setting the parameters. It start with setting the RPM first. Okay, in this case, we set it like 1500. Then the run duration, we set it around like 20 seconds. Then the pause time is around 20 seconds as well. Then the number of cycle is made to 5, okay, just to show that it can be changed. Then you basically just start, so it's running, so you can see. Okay, now the next one will show the how the inner one is rotating. Okay, so these settings are very simple. Okay, you have the RPM setting by rotating this button, and other one is digitally adjusted for the duration. Now, when you run the system, this is how it rotates. So it gives. So this is at the rotation speed of 2000. At 2500, you can see, yeah. Okay, it's really at very high speed. And this is in the slow speed. Usually, yeah, this video we have taken with the safety switch off. But when user gets the equipment, it's with the safety switch. So you are not able to see this movement while running the system. Okay, these 3 videos just give you a quick snapshot or glimpse how this instrument is functioning and how you are taking the sample and how you are doing the pre-cooling with the liquid nitrogen in the container. So we have developed an application booklet that really shows the grinding of different type of material. Okay, so it comes with some different type of synthetic polymer and biopolymer. So you can go to our website and download, or later we will share this slide set also. So from this QR code, you can also download this application booklet. Now I'm going to share few of application for each of this category and highlight some of the operation condition and the performance that we have accomplished. So when it comes to synthetic polymer, okay, so we have tried over 20 typical synthetic polymer, and that are listed down here also, starting from this high density polyethylene, low density polypropylene, polystyrene, and so on. So as you know, all these polymer comes with different glass transition temperature. Okay, some really they are like a minus 100, minus 50 range, and some are of this minor like 100, 150, and so on and so forth. So similarly, the melting point of this different polymer also can go like as high as 350, and some carry small, and same for the tensile strength also. So with the high tensile strength, sometimes yeah, the challenge or difficulty in crushing, and in addition, we also will face the challenge of the temperature that is sometime hitting the glass transit temperature or melting point. So for that reason only, we have to consider this pre-coding. Okay, so this slide basically tells again the type of polymer that we have tested. and their brittle temperature. So when your brittle temperature is such very low, like minus 250, 135 and all, it's really a tough samples, and these are the samples we have shown how this can be like milled with our cryomill. Okay, so in this slide we are showing PTFE, polycarbonate, natural rubber, and PIG. So they're all operated. Okay, we have used the large titanium sample container, and using the SS rod, the stainless steel rod, and pulverization is done under this cryogenic cooling, and sample amount is around like 0.5 gram, and the RPM is 3000. The run time is 30 seconds, and pause in between 20 seconds, and around like 2 cycles. That means it's considered one repetition only. Okay. So basically, you can see all these samples, like all these different 20 over polymer samples that we have tried. We can see they're all really coming in powder form. Then we can use this material for any type of analysis, for morphological study or for chemical analysis as well as. So let me briefly go through few examples with some details. Okay, so this one basically is the silicon sample. Okay, uh, okay, silicon resin, this PDMS. So as you know, the silicon resin has got it's one of the synthetic polymer, and that has the main skeleton of siloxane bonds, and it's colorless, odorless, and has got this water repellency and oil the resistant, oxidation resistance, so on and so forth. Okay, it's actually it has a properties of metal oxide like base type. So that means it is weak against some of the strong acids. This PDMS is used in different industry, including this contact lenses, medical devices, okay, and also lubricants and microfluidics. Okay, so when you want to analyze this for some physical, chemical, or mechanical characterization, again, making a homogeneous sample is important. And here we show how the cryomill can really help to do this. Okay, we have taken around like 0.5 gram of sample and cryogenic grinding. Okay, and we use the tungsten carbide ball, and the milling speed is around 3000. Grinding time is 20 seconds in between. So number of repetition is 1. So we are able to get this PDMS ground to like 100 micron or less. So the second example that I'm sharing here is the natural rubber. Okay, so natural rubber, again, it has got excellent mechanical characteristic. Okay, for tensile strength, tear strength, wear resistance, and it's used in tire industry, rubber belts, hoses, footwear, etc. Okay, now this sample basically we show the difference of one repetition versus the two repetition. Okay, so for both case, we have used same speed. Okay. When we say second repetition, it's only the pre-cooling is done for 5 minutes, whereas the first time it is done for 10 minutes. So we can see the powder basically do not see a big difference between this 1 cycle and 2 cycle, and even the particle size also in this particular case. Whereas in some cases, you will see the benefit of the repetition. So the third example that I'm showing here is actually the peak material, which is again inert and very, very, very rigid, and so it has a glass transition temperature of like 143 and melting point of 343. So again, it has got excellent flame resistance, mechanical properties, etc. And here again, we are showing the grinding of these pellets or peak pellets into a powder. Okay, then in terms of the This peak material, we can do it in room temperature as well as cryogenic. So, but many other samples, cryogenic cooling will be mandatory. Okay. So we have used grinding wall of tungsten carbide. Okay. Then this is the milling time and so on and so forth. So you can see the benefit quickly. Now I move on to the biopolymer again. So we have tested the sorry, tested the instrument performance for different type of bio materials. Okay, like teeth and shellfish shell and also wood chips, and some, yeah, we can do it in room temperature. Some we need the cryomilling. So you can see the material before grinding and after grinding. So here, yeah, some cases we have used cryo, and mostly the RPM is like 2520 seconds and up to 4 cycles. So again, cycles are not repetition, just 4 cycles within one repetition. So this boar canines actually is as a hard as crystal is. Okay, so this is something men like people have used it for studying the nuclear accident effect for this transient analysis aging purpose. And yeah, this sample can be easily crushed into powder form with our cryomill and room temperature grinding versus the cryogenic grinding. So yeah, it's much faster and you can get a real powder sample that can give you better data in terms of the sample homogeneity. So this is another example of this young shoot, okay, from this bamboo, and that's used for DNA research, okay. In this case, again, yeah, it's a room temperature, even wet sample, okay. So we have actually a disposable polypropylene type container for this kind of biomaterial. So we don't have to use this stainless steel or the titanium based one. For biomaterial, we have this polypropylene type. Okay, in this case, the milling speed is 2000 and grinding, the time is 10 seconds, pause, then 2 cycles. Okay, so you can grind this material to get like 50 microns particle size. So the last group of material that has been tested with our equipment is the inorganic material like ceramics, fused silica, sand, and tea pottery. Okay, so unfortunately, diamond is something we have not tried. So ceramics, yeah, fused silica, and they all come with a different strength, as you know. Now, I just want to move on to show the importance of particle size when it comes to analysis. Earlier, I have shown one example. Okay, now I just want to share some additional insights into this sample size and shape when it to pyrolysis GCMS. So here I'm taking an example of this microplastic analysis as an example. Okay. So the first example I'm showing is the polystyrene. Okay, when you use the polystyrene in different forms, okay, and how the ratio of this styrene trimer to styrene vary. So normally polystyrene, you can dissolve it in dichloromethane. So as a solvent form, you are like getting the best reproducibility as expected. Whereas when you use a different particle size, okay, from fine powder to particles of different diameter, then your RST really vary. So this is one thing that tells it's important to use a cryomill to really powder your sample before the analysis. So we have carried out some experiments with polystyrene, okay, from raw pellets under different conditions to get different sizes. Okay, so we have used grinding ball and we also added additives like this 2 ml of 85% ethanol. Okay, after grinding, the sample is collected on ethanol is stripped off through some heating on the hot plate. Then the particle is analyzed first for particle size distribution, then subsequently analyzed for the uh, pyrolysis GCMS. So you can see the size distribution pattern also, which is again influenced based on the RPM and the cooling, okay, effect of cooling. Both are critical in this. So we have obtained deliberately 4 different sizes, okay, 230, 185, 90, and 65. And they have been analyzed by our pyrolysis GCMS, okay, and just to compare the virgin sample with the solvent cast, so we have dissolved it in dichloromethane and we have taken one fraction for analysis. So now we can see this is a typical chromatogram or the pyrogram you obtained for polystyrene analysis, which shows the monomer peak, dimer, and trimer peak. So here we have compared the what's called the ratio of styrene trimer over styrene monomer. So as expected for the solution form, we have a better ratio, whereas this is slightly on higher side for the powder. So it's always recommended if we can bring it to solution and do it as a solution is the best thing. But many of these polymer do not have the solubility. So we have to compromise a little on the reproducibility and sensitivity, then get the best out of it. So when we compare the relative standard deviation for different sizes, as the size get smaller, just a minute. So you can see the RST is improved. So you have a best reproducibility or the relative standard deviation for the smallest size. Okay. Another important reason for a better reproducibility in solution form is because as a film sample, it's as a liquid, it is uniformly spread across, whereas as a powder sample, depending upon the particle size, so all particles may not be receiving exactly same temperature. That could be one reason for this small difference. So another example to really emphasize on this importance of particle size and grinding of sample before analysis, we have taken polyethylene tetraphthalate powder. Okay, it's like the pellets into powder. Again, through cryogenic grinding under different condition, we managed to get particles of different size, 460, 280, and 106 to 280, and under 106. And so when you do a flash pyrolysis of PET sample, generally you get typical peak for divinyl terephthalate and benzoyl like oxyethyl vinyl terephthalate and ethylene glycol. So again, the peak area of this has been compared. Excuse me. So we can see the best relative standard deviation or reproducibility is obtained for the smaller size compared to the higher size. So these two examples, because one is when you show the effect of this grinding for making different sample into powder form and how it is really contributing to the data quality when you do the chemical analysis. That is something we try to demonstrate by analyzing two different type of polymer like polystyrene and PET, and where we have shown the better data quality when you have the samples of smaller particle size. Okay, so this instrument comes with all necessary aids or accessory so that you don't have to order things separately. So the instrument comes with the vessel and crushing ball. So the vessel, as I said, the stainless steel titanium dioxide, we also have the PP type. And crushing ball, we have zirconia, tungsten carbide, also the SS rod. And for cooling purpose, we have this cooling container, tongs, and the sample holder. Also, it comes with the sieve for saving the sample to get the smaller size for your analysis. Okay, in terms of the specification, yeah, it's I think again you can get all this information from our website. Okay, which I'm not going to read again because some of this we have discussed during the earlier time. So now some of the participant may have a question, how does it compare to the products that are out in the market? So there are certain product available from different manufacturers. So in short, we really have a value proposition in terms of the performance and cost to really help the customers to minimize your efforts on this sample milling, and also the ownership cost is much lower compared to others. So you can see the weight is almost like lowest weight, and consumption of liquid nitrogen, then also the number of samples. Okay, all this. So we have some unique value proposition. So that will really have the kind of pressing reason why we should consider the Frontier Laboratories IQML. Okay, so the take-home message, yeah, basically in this webinar, we wanted to introduce our new cryogenic mill that has got some unique features. It can do the crushing, efficient crushing in short time, and it is easy to use and simple operation. And we use a pre-cooling approach to minimize the consumption of liquid nitrogen. So with that, I would like to thank you all for your kind attention. Yeah, thank you very much.